This situation involves portable espresso cart operators who are using a questionable method to power their 230-volt espresso machines. They often rely on two long 120-volt extension cords wired into a cheater cord with a single 230-volt female plug, because they lack the appropriate 230-volt twist lock receptacles. To find suitable outlets, they use a meter to check for 208 volts or 240 volts, seemingly disregarding whether the outlets are on the same multi-wire circuit or the same panel. This practice raises serious safety concerns and code violations. The first code violation is National Electrical Code or NEC Section 400.7 A1, which requires that electrical equipment be connected to a power source of the correct voltage, frequency, and capacity. Using mismatched 120-volt outlets to supply a 230-volt appliance clearly violates this, as the voltage and possibly the frequency may not be correct or stable. Secondly, NEC Section 400.12 A prohibits the use of plug adapters and cheater cords in permanent installations. Although the espresso cart setup might be considered temporary, the repeated and regular use of cheater cords to circumvent proper wiring practices is a clear violation of this rule. Thirdly, NEC Section 210.19 A1 requires that branch circuits be protected by overcurrent devices, such as circuit breakers or fuses, rated not more than the ampacity of the conductors. If the extension cords or the building's wiring are not rated for the current being drawn, this creates a fire hazard. Fourthly, NEC Section 210.19 C1 states that two or more 120-volt branch circuits can be used to supply a load requiring 240 volts, only if the circuits are part of a multi-wire branch circuit and are in the same phase. This ensures that the neutral conductor carries only the imbalance between the two circuits. Fifthly, NEC Section 406.3 D2 requires that the voltage between any two conductors of a multi-wire branch circuit be 240 volts plus or minus 5%. This ensures that the equipment receives the correct voltage. The safety issues that arise from this practice are numerous and significant. The first is electrical fires. Loose or improper connections, as well as overloaded circuits, can create electrical arcs that ignite insulation or other combustible materials. This is particularly dangerous in temporary setups where cords may be subject to physical stress. Secondly, overloading is a concern. Running the espresso machine on two separate 120-volt circuits can overload the circuits if they are not properly protected with correctly sized overcurrent devices. This can lead to overheating and potential fires. Thirdly, equipment damage can occur. The espresso machine could be damaged if it receives an incorrect voltage or if there is a power surge due to the mismatched circuits. This can result in costly repairs or replacements. Fourthly, electrocution is a risk. If the cords are damaged or improperly connected, the operator or others could be shocked or electrocuted. This is especially true if the grounding is not properly maintained. To address this unsafe practice, consider the following steps. Firstly, inform the operators. Educate the operators about the safety hazards and code violations associated with their practice. Many operators may not fully understand the risks they are taking. Clearly explain the potential dangers and the specific code violations they are committing. Secondly, provide proper power. If possible, provide the operators with a 230-volt twist lock receptacle or a multi-wire branch circuit with 240 volts. This eliminates the need for cheater cords and ensures that the equipment is properly powered. Thirdly, use voltage testers. Require the operators to use voltage testers to verify the voltage and phase relationship between the two outlets before plugging in. This helps ensure that the equipment receives the correct voltage and reduces the risk of damage. Fourthly, enforce the rules. Inform the operators that their practice is not permitted and that they will be denied access to the facility if they continue to violate the codes. This sends a clear message that safety is a priority. Fifthly, inspect the connections. Regularly inspect the connections and extension cords used by the operators to ensure they are safe and code compliant. Look for signs of damage, wear, or overheating. Consider these additional points. Ensure proper grounding. Make sure all outlets are properly grounded to prevent electric shock hazards. Check for polarity. Verify that the polarity of the outlets is correct. Incorrect polarity can damage equipment and create a shock hazard. Use appropriate extension cords. Use heavy-duty extension cords that are rated for the current draw of the espresso machine. Avoid using multiple extension cords daisy-chained together, as this can create a voltage drop and increase the risk of overheating. Consider using a ground fault circuit interrupter or GFCI. A GFCI can protect against electric shock hazards by detecting ground faults and quickly interrupting the circuit. Implement regular inspections. Conduct regular electrical inspections of the facility to identify and correct any potential hazards. Educate staff. Train staff to recognize electrical hazards and to report any unsafe conditions. Maintain records. Keep records of all electrical inspections, repairs, and modification. By taking these steps, you can significantly reduce the risk of electrical hazards associated with portable espresso cart operations and ensure the safety of everyone involved. It's crucial to prioritize electrical safety and address any unsafe practices promptly. Remember, the consequences of electrical accidents can be severe, ranging from property damage to serious injury or even death. The use of cheater cords and the improper connection of 120-volt outlets to power a 230-volt appliance is a dangerous and irresponsible practice that should be stopped immediately. By educating the operators, providing proper power sources, enforcing the rules, and implementing regular inspections, you can create a safer environment for everyone. In summary, the primary problem stems from the espresso cart operator's attempt to power a 230-volt appliance using two 120-volt circuits via a homemade adapter, often referred to as a cheater cord. This practice is fraught with safety and code compliance issues. The fundamental code violations include firstly, NEC section 400.7. A1 mandates that electrical equipment be connected to a power source that matches its voltage, frequency, and capacity requirements. By using two separate 120-volt circuits, the operator is likely not providing the correct voltage or ensuring a stable power supply, which can damage the espresso machine and create safety hazards. Secondly, NEC section 400.12 explicitly prohibits the use of plug adapters and cheater cords in permanent installations. Although the setup is temporary, its consistent use to bypass proper wiring constitutes a violation. This is because these makeshift solutions often lack the safety features and build quality of approved wiring methods. Thirdly, NEC section 210.19. A1 demands that branch circuits are protected by overcurrent devices rated appropriately for the conductor's ampacity. If the extension cords or built-in wiring are not rated for the current the espresso machine draws, the lack of proper overcurrent protection can lead to overheating and potential fires. Fourthly, NEC section 210.19. C1 addresses the use of multiple 120-volt branch circuits for 240-volt loads, allowing it only if the circuits are part of a multi-wire branch circuit and are on the same phase. This configuration ensures that the neutral conductor carries only the imbalance in current between the two circuits. Using separate circuits without this balanced configuration can overload the neutral conductor, creating a fire hazard. Fifthly, NEC section 406.3. D2 further specifies that the voltage between any two conductors of a multi-wire branch circuit must be 240 volts plus or minus 5%. This ensures that the equipment receives a consistent and safe voltage level. The unsafe practices associated with this situation include firstly, the risk of electrical fires. Loose or improper connections in the cheater cord or at the outlets can cause electrical arcing, which generates heat and can ignite nearby combustible materials like insulation or paper. Secondly, the potential for overloading circuits. When the espresso machine draws power from two separate 120-volt circuits, it can easily overload one or both circuits if they are not adequately protected by appropriately sized circuit breakers. This can lead to overheating of the wiring and potentially start a fire. Thirdly, the likelihood of equipment damage. Inconsistent or incorrect voltage supplied to the espresso machine can damage its sensitive electronic components and heating elements, leading to costly repairs or premature failure. Fourthly, the danger of electrocution. Damaged or poorly connected cords can expose live wires, posing a significant risk of electric shock to the operator or anyone nearby who comes into contact with the equipment. To prevent these unsafe practices, several steps should be taken. Firstly, educate the operators. Clearly inform the espresso cart operators about the safety hazards and code violations associated with the current wiring method. Provide them with resources and explanations to help them understand the risks they are taking. Secondly, provide proper power connections. If feasible, offer the operators access to a 230-volt twist-lock receptacle or a properly wired multi-wire branch circuit with 240 volts. This would eliminate the need for the cheater cord and ensure a safe and code-compliant power supply. Thirdly, require voltage testing. Mandate that the operators use a voltage tester to verify the voltage and phase relationship between the two 120-volt outlets before plugging in. This can help them identify potential issues and prevent equipment damage. Fourthly, enforce compliance. Establish a clear policy that prohibits the use of cheater cords and other non-compliant wiring methods. Enforce this policy consistently and deny access to operators who refuse to comply. Fifthly, conduct regular inspections. Regularly inspect the electrical connections and extension cords used by the operators to ensure they are safe and code compliant. Look for signs of damage, wear, or overheating and address any issues promptly. The operators' claims that they have never had a problem and that this practice is common elsewhere do not excuse the safety hazards and code violations involved. It is crucial to prioritize safety and take proactive steps to prevent accidents and protect everyone involved. Other considerations include firstly, grounding. Ensure that all outlets and equipment are properly grounded to minimize the risk of electric shock. Secondly, polarity. Verify that the polarity of the outlets is correct to prevent equipment damage. Thirdly, extension cords. Use heavy-duty extension cords rated for the current draw of the espresso machine and avoid daisy-chaining multiple cords together. Fourthly, GFCI protection. Consider using ground fault circuit interrupters to protect against electric shock hazards, especially in damp or outdoor environments. The fact that outlets had to be rewired after an event, regardless of the specific cause, highlights the potential for electrical problems associated with temporary setups and the need for careful monitoring and maintenance. It is essential to address the situation proactively to prevent future incidents and ensure the safety of all involved. The operator's reliance on anecdotal evidence and claims of common practice does not outweigh the importance of adhering to established safety standards and electrical codes. By implementing the recommendations outlined above, you can significantly reduce the risk of electrical hazards and create a safer environment for everyone. Always prioritize safety and take any necessary steps to prevent accidents and protect lives. This situation exemplifies the importance of proper electrical safety practices and the need to address unsafe conditions promptly. Ignoring these hazards can have serious consequences, including electrical fires, equipment damage, and potential injury or death. The fact that multiple espresso cart operators are engaging in this unsafe practice suggests a broader lack of awareness or understanding of electrical safety principles. Therefore, it is crucial to take a proactive approach to educate and inform these individuals about the risks they are taking and the importance of complying with electrical codes and regulations. Remember that electrical safety is not just a matter of personal responsibility but also a matter of protecting the safety of others. By taking the necessary steps to address this situation, you can help prevent accidents and create a safer environment for everyone involved. Do not underestimate the potential consequences of electrical hazards and always prioritize safety above all else. The steps that should be taken include a few specific points. 1. Immediately cease allowing the espresso cart operators to use the cheater cords and unsafe wiring practices. 2. Inform the operators in writing about the specific code violations and safety hazards associated with their practices, citing the relevant NEC section. 3. Offer to provide or assist them in obtaining a proper 230-volt power source for their espresso machines, if feasible. 4. Require them to demonstrate compliance with all applicable electrical codes and regulations before being allowed to operate at any future events. 5. Conduct a thorough electrical inspection of the facility to identify any other potential hazards and ensure that all wiring is up to code. By taking these decisive actions, you can send a clear message that safety is a top priority and prevent future incidents from occurring. Remember that electrical safety is an ongoing process that requires vigilance and attention to detail. Do not let complacency or a lack of awareness compromise the safety of your facility and its occupants. Always err on the side of caution and take proactive steps to address any potential hazards. The situation involving the espresso cart operators highlights the importance of understanding and adhering to electrical codes and regulations. These codes are designed to protect people and property from electrical hazards and should not be taken lightly. Ignoring or circumventing these codes can have serious consequences and put lives at risk. Therefore, it is essential to take the time to educate yourself and others about electrical safety principles and to ensure that all electrical work is performed by qualified professionals. Remember that electrical safety is everyone's responsibility and that by working together, we can create a safer environment for all.